Cruz. I am a senior in the Civil Engineering Department. I'm here with Chase Bell, Andrew Butler, and Lauren Hughes. We are all representing Kennesaw State University, and we're here to discuss our project of comparing different methods of carrying high precision vertical control from a monument to a monument or to different job sites. Our team decided to test two different methods to analyze the degree of accuracy achievable to find the most reliable method for use in real-life applications. And then we decided to use the more precise of the two to follow the procedures set by NGS to set a benchmark on our campus. After communicating with the National Oceanic and Atmospheric Administration, as well as our advisors, and discussing several topics, we decided to use the two most common methods used to establish vertical control in surveying today, which are trigonometric leveling with the robotic total station and differential leveling with a digital level. We proceeded with running multiple loops between two NGS benchmarks and a third Cobb County benchmark that were located on our campus. We used both instruments and multiple combinations of our team in order to gather data for the comparison. Our goal was to travel from Trommel to the BV Monument to the Cobb Monument and then back to Trommel with the least amount of vertical misclosure and to meet the standards of an NGS second order class 2 placement in order to match the data sheets provided by NGS for Trommel and BV. Now I'll hand it over to Chase, who will go through some of our procedure and tell you more about our monuments.
Thank you. All right, so to begin, I'm going to give a little bit of information about the monuments. So on our campus, we had two NGS monuments, which is Trommel and BV 033202. Trommel was actually named after one of our professors, Al Trommel, and he pioneered the surveying and mapping program at Southern Tech, which is now Kennesaw State, where we go. Trommel is a second order class 2 monument, like Allison said. BV is actually as a Georgia Department of Transportation monument. It was set for future widening of the road, and it is a second order class 2 monument also, and it was accepted by NGS standards. Cobb 01 is a Cobb County Department of Transportation monument. Since it's not an NGS monument, there was no NGS data sheet on it, so we had to make a few phone calls to the Cobb Department of Transportation. And after a while, they provided us with a data sheet with an elevation, so we could use it within our loop to check elevations. Since BV and Cobb and Trommel are near some roadways, safety was a major concern. We made sure to wear bright safety vests when walking over the roads or anywhere around the campus. We used crosswalks when crossing the streets. The good thing about it is that most of our loop didn't really happen on streets, so that was a good thing. And we only set one rebar throughout our project, and it was when we were setting a monument. And there was a building that was demolished earlier, and they had all the utilities marked before, so we made sure we were not near any kind of electrical or water utilities. And now Lauren will talk about the difference between differential and trigonometric leveling.
So what's the difference? We first began by discussing the difference between the two leveling methods. In differential leveling, the equipment used is a level and a level rod. The level is mounted on a tripod and takes a reading to the level rod. The rod is moved to a new location and the elevation is transferred using mathematical calculations based on the different readings. When reading a level, it only measures a zenith angle at 90 degrees. Horizontal lengths of the backside and the foresight should be kept similar to eliminate the effects of curvature and refraction. This is the differential level we use, or differential level we used. It's a TopCon DL102C, a digital level, and we used a barcode reader. In trigonometric leveling, a total station and a prism is used. A total station is mounted on a tripod and takes the measurement to the prism. A total station can measure any zenith angle, and using mathematical equations, the elevation is computed, taking into account the zenith angle that was measured. Unlike differential leveling, the backside and foresight distances do not need to be similar, as we can correct for curvature and refraction with equations. This is a Trimble robotic total station. This is the one we used in our trig leveling. First method we tested was trigonometric. We began our field work with the trig level loop. We commenced at BB Trommel, and we traversed up, at benchmark Trommel, we traversed up to BB 033202, then down to the Cobb 01 monument, and then back to Trommel to close our loop. We used a Trimble robotic total station. We mounted our prisms on tripods for maximum accuracy for our back sights and our fore sights. We used the direct reverse method for 2 opposing angle readings at each setup for analysis. Now Andrew's going to tell you more.
For the next portion of our project, we moved on to our differential levels. You can see the equipment we used here, again, was that Topcon DL102C digital level with a barcode rod. This instrument was set to take 3 shots on a target and then average those shots together and display the result out to the 4th decimal place. You can see our loop here, which is very similar to our trigonometric loop. We commenced at Trommel, ran up our hill to the BB monument at the top of the hill, and then back down to Cobb 01, and then closed our loop at Trommel. We ran this loop twice. The difference between the first and the second was that on the first one we actually checked in at a couple turning points, PK nails that were set during the trigonometric loop, and the second one did not. These were the results of our first differential loop. The vertical misclosure came out just under 400ths, which was kind of surprising. This was more accurate than the trig level loop that we had just done, which we thought was kind of confusing. We imagined that the trig loop, before we started, we thought that it would be more accurate than the differential. So we decided to test if we could repeat this level of accuracy with the differential loop, and we conducted a second differential loop. On this one, again, we did not check in at turning points that were set during the trig loop. But we found quickly that our accuracy was repeatable, and we actually did better accuracy on this one than the first one. So overall, we found that for this differential loop, it required a careful and sometimes patient crew. It was highly susceptible to human error and also some interference from the weather. There were times that when we were out in the field, there was higher than normal winds, and especially with the barcode rod at the full height, started to sway in that wind very easily. But still, we managed to close this second differential loop with just about roughly 300ths vertical disclosure. So in the aftermath of this field work, we adjusted our data and moved on to our analysis, which Chase will now talk about.
All right, so to begin the analysis, I'm going to start off with the differential level loops. So for the differential level loop, we compared the vertical misclosure between the field elevations and the NGS published elevations. We used Trommel as our control. So a BB monument on the first loop had 1300s vertical misclosure. The Cobb monument had around 500s vertical misclosure. On the second loop, Trommel was our control. So BB monument actually had 27 thousandths vertical misclosure, and Cobb monument had 29 thousandths vertical misclosure. Now looking at the trigonometric loop, we noticed that our vertical misclosure tying back into Trommel was 1400ths error, which is a lot of error. So we started to wonder where this error came from. So we looked at how our field elevations compared to the published elevations, and at Trommel we were 1400ths vertical misclosure. BB monument was around 300ths vertical misclosure, and the Cobb monument was around 900ths vertical misclosure. Looking at the data, you can see that most of our vertical misclosure happened on the second half of our loop, going from BB to Cobb back to Trommel. And just so happens that that is the portion of our loop that has the highest vertical difference between monuments, because the vertical difference between BB and Cobb is 82 feet in length, or in elevation difference. So we thought maybe the extreme zenith angles were at fault for our amount of error. So to check for this, we compared our elevations of our trigonometric loop with the first loop that Andrew and them ran. And to look for any kind of error that happened at that later portion of our loop. And looking at our elevation difference, it's pretty steady throughout the loop, so we don't think that just that one particular part of our loop was at fault. but instead, talking to the crews, everyone there is kind of learning, and there was different field procedures because some of the students interned with other companies. So we think measuring the height of the instrument and the height of the rods was the reason for our 1400s error in the trigonometric level. But looking at the data, of course, the more accurate of the two is differential leveling. So we use that in order to go about setting our monument, which Allison will talk about now.
In 2008, with the widening of our main entryway, our campus lost a monument that had been in place for many years. With the competition subject of high precision vertical control being announced, we decided to expand our professional knowledge by following the NGS standards to set a monument on campus. After completing the first part of our competition and determining that digital differential leveling was the most reliable method to establish a monument, we began the process by determining an appropriate location. We decided that the new monument should be placed next to Stinger Cafe, which is our main dining hall on the Marietta campus. At this site, it will lie undisturbed for many students to use for future generations. We also voted on the name SPSU 17 as a nod to our team's heritage, being that we were Southern Poly before the merger with Kennesaw State in the past year and a half. We then researched the NGS standards and followed the procedures prescribed. We began with running a double leg from the BV monument to the site selected, and then placing a plastic-covered iron pin. We then ran a single leg to trommel and followed with an analysis of our data. The loop going from the BV monument to SPSU 17 and back was found to have a vertical misclosure of 2/100. From trommel to SPSU 17, we had a vertical misclosure of 5/1000. The degree of accuracy that we achieved was comparable to the two NGS monuments that were used, which places it as a second-order Class II monument. We plan on completing the procedure again a couple of times before the end of the spring semester in order to place a poured concrete base for mounting a new brass plaque in, once permission has been granted from our school. So Chase will now discuss a couple of things that we learned during the process.
So overall, it was a good learning experience for us all. After doing loops a couple times, we learned some new ways that we could improve if we were to do this in the future. And one thing we do, we could increase the number of loops ran between the differential and trigonometric loops. And that way we could have more data to analyze and compare. So if one day you do something wrong, you can throw that out. You have more data to compare. One thing we could do is incorporate the benchmarks as terms within the loops itself, because when we did our loops, we actually took them as intermediate foresights, and after learning and everything, we figured out that that would be the proper way of doing it, is to include it as terms. And another thing we can do is standardize field procedures. So that way, measuring the height of the instrument or the height of the rod, it doesn't have, I guess, as much of a chance of being messed up. And yeah, but overall, it was a good project. We definitely learned a lot from it. That was cool because on our campus, we got to set up throughout the campus, and students got to come up to us and ask us questions about it, and it kind of sparked some interest. So that is good to spark interest in the surveying field for our school. But yeah, so we want to thank y'all for listening, and we'll now take y'all's questions.
Just wondering, when you ran your the two different types of loops between the differential and the trigonometry, did you keep your legs about the same size, your distances you were shooting, or were you shooting a longer distance when you did the trigonometric one?
To begin with, we tried that, but as you can see from the western side of our campus, it's an 80-foot difference in elevation, so working down that hill was pretty tough. So we had some shots that were probably about like 15, 20 feet apart from each other, and other ones we tried to keep standard. So it was just due to the terrain, we weren't able to keep that as constant as we probably could or should have.
So when you were doing the trigonometry one, you took longer shots and didn't stick with just the 15 feet shots?
Yes, ma'am, we did.
We did manage to keep all of our shots for the differential level within the 66 feet.
How did you measure the HI of your reflector when it was setting over your benchmark?
On the prism, the way that we were, that the people who ran it learned from the nail measure up to the mark on the reflector has a little line for the midpoint, they measure up to that. So I think people measuring up to that differently in the field, maybe that because I know some people measure to the actual center of the prism, some people measure to that side area. So I think that was probably the reason why we had such a big area.
Yeah.
But, so one thing that we need to do next time is standardize field procedures to make sure that errors like that don't occur.
Had you considered at all using fixed height tripods when doing the trigonometry?
We thought about it. Our idea was to see if, like, because every day out in the field, we usually keep up with rod heights and instrument heights. So we thought to see if what we do in the field is accurate enough to carry high precision vertical control. And based on what we did as students and learning, it didn't even compare towards the differential leveling. So.
Any other questions? Questions from the audience?
Yes, sir.
Can you explain why you thought trig leveling would give you better results than differential?
Well,
I think we all thought in the beginning that because when we were setting up for the trig leveling, all the prisms were on tripods, they were all stabilized, that because of that, it would be more accurate as compared to somebody just holding the barcode rod, and then that being impacted by, the person's ability to keep it steady, the wind, everything that would go into that, as opposed to just a tripod, which would be stable. So that was our thought process on it originally going into it, and then that was proven wrong by our results.
Yes, sir.
When doing your trigonometric levels, did you use both faces on your observations, and how many sets did you turn, if any?
We actually used the direct reverse method. I believe it took about 3 repetitions every time. So it was, and then I averaged all of them, just got that one particular reading. So.
Thank you.
So 13 centimeters seems like a lot to miss close by. How are you going to go back before you do the loop again?
The trig was actually set with a differential level, which is the more accurate of the two, which was 300 there, I believe.
Yeah, and it's hundredths of a foot. not
Hundredths of a
13
foot.
centimeters.
Yeah. Sorry
Okay, I
about
thought
that.
that was meters.
Yeah.
Yeah.
Any other questions? Okay.
Thank you all
very much.